She's head of machine learning at BBC. Prior to that, she was director of machine learning at AIG, research associate at Imperial College London, and many other different interesting things. And she'll talk about applications of AI in news and media.
So thank you everyone for coming in such a large number. I've since slightly changed the title of my talk, and it's going to be about data for good, unlocking the BBC archive. But before I do that, I just want to introduce what my team does at BBC in general, apart from what you will see in the continuation of the talk. So we are a part of a team within research and development, and we do all sorts of things for the production cycle in the BBC, as well as some supporting models. So for example, we build recommender engines for the iPlayer. We do a lot of transcription work of audio content. We do a lot of NLP and a lot of computer vision models. So today I'll be talking about the work that we've done in the archive. And with that, I want to share with you something that kind of resonated with me during these couple of days. Being here, poetry will be written by everyone. It's a very famous poem by a Serbian poet, Branko Milković. And it actually is, we are at this point where everyone everywhere is applying AI. And the technology is going to be as ubiquitous as utilizing personal computers. So if we, think 50 years back when personal computers have been used by very few people at their workplace, and now it's a commonplace and no one even talks about it, I think similar stands for AI. We are at this point where more and more people is using these models and benefits from them. And BBC is writing poetry as well. So BBC Archive is one of the largest multimedia archives documenting BBC's broadcasting history. We have 1.5 million videotapes and 7 million photographs and numerous other paper documents and audio documents. So to put it in a perspective, we have around 23 petabytes of data in this archive, which is equivalent to 100 years of HD video. So needless to say, this type of database is difficult to mine, because simply a couple of years ago it has not even been transcribed. And what we've done, my team, is transcribed a lot of this audio and video content, so then the archive is now searchable by keyword. Then we've done a lot of NLP in terms of tagging and labeling, and now you can kind of search by tag. In the future, we're planning to do some sort of semantic search, almost like Google search for BBC archives. And at the moment, we're working on restoration of video and audio content at scale. Okay, so just to go a little bit into the detail of what we do with transcription. So we built the system 6 years ago now, and saved BBC millions and millions of pounds. Given how big the archive is, it was not considered viable to use third-party services for this type of transcription activity. And a couple of years back, everyone was working with a system called CALDI, a very traditional speech-to-text system, which kind of consists of a couple of different models within it, transcoding, then you have voice activity detection, speaker diarization, and then you need to do some punctuation and capitalization, and then finally deal with your output. So it's basically like 5 models stacked into one, and it's the language models that the system's using is very traditional hidden Markov models and so on. But a couple of months ago, OpenAI open sourced a new transcription speech-to-text model, which is based on transformers, and it's called Whisper. And of course, the first thing that we've done is, wanted to evaluate it, whether it makes sense for us to kind of use it instead of Caldi and kind of get some improvement in the accuracy. Because I'm not sure whether I mentioned, but at the moment we have 25% word error rate, which means like every 4th word is wrong. But of course, it's like just mean. So when it comes to different accents within UK, like we're much better on a London-based accent and much worse on, let's say, when we need to transcribe something coming from Scotland or something coming from Northern Ireland. So the hope was to kind of rectify this a little bit and to evaluate the Whisper's OpenAI's Whisper model. And as I said, nothing new again, like a big transformer with a huge amount of data, around like 650,000 hours. Our model, the Caldi-based one, was trained only on 4,000 hours of video material, whereas this one used like a couple of orders of magnitude more. But of course, it cannot be kind of applied out of the box. So we've just done recently a couple of testing on it. It has the model has certain limitations. It cannot be run on GPU at all. It's very slow. It takes kind of 4 times more to transcribe the content than the duration of the content itself. So it's really not sustainable. And there are other problems with it, like a speaker diarization. It doesn't do it, so it's not very suitable for, in a sense, for all use cases. But when all said is done, even medium Whisper model, has 11% word error rate on our data. So you have kind of performance metrics that are that can be found in the paper, which are mainly on the academic data set. But what we've done, we've used an evaluation data set which kind of spans different accents across the UK, and it came down to 11.5%, which is amazing when a human level accuracy is around 9%, when they call it like a quick human transcription is around 9%, and if people spend more time, it's around 4 or 5%. So this is almost as close to perfect as one would actually wish for. Then the other thing that we're doing is, as I was saying, using a lot of NLP to tag all of these transcripts. So one reason why we need more accurate transcripts is to kind of have better performing NLP models. And to do this, we use some topic modeling, we use different text representations, and so on. So I won't go very much into detail about this. What I like to focus on is the restoration work that we've done and some computer vision things that we're doing with the archive content. So then, just to put this in perspective, we have, as I was saying, 100 years, equivalent to 100 years of HD content. So it's impossible to actually take all of this content and to restore it and to bring it to a level of quality that is sufficient for you then to use it in downstream content creation processes. So it is expensive, it is time consuming, it requires manual intervention, it requires artistic experience, and recently there's been quite a few successful restoration works, notably Peter Jackson. He's had 2 documentaries, one about the Beatles, one about the World War I, and it took years and hundreds of people for him to kind of create these documentaries. And he did use AI and some AI systems within his pipeline. So definitely a very lengthy and time-consuming process. So this is just one exemplar of what some of our archive content looks like, and this is one of the better ones. Sir David Attenborough talking about color TV. And you know, it's a very noisy footage. It has a lot of artifacts, as you can say, this kind of noises, scratches, and so on. So all in all, not perfect. So what our pipeline looks like, we have what we do is first denoise the footage, then remove physical damage artifacts, we correct lights, we then do the resolution enhancement, frame rate enhancement, rotoscoping, segmenting images, and colorizing of these images to kind of get finally one restored, colored, fully restored and colored video. So this is just, so the first batch of processing that we are doing is the one in the restoration part, so meaning removing noise, removing physical damage, artifacts, and correction of light, and then finally colorization. So that being said, we're using a lot of newest academic research and open source models, but the problem with the open source models is that they are built and adapted to a different type of data, typically CCTV footage. And we do need to spend quite a bit of time of adapting these models to our use case, which also kind of makes it interesting. Yeah? Okay, I had, I think, one slide which was... So this should be played, I think. Okay, let's just wait a little bit. This should be the final result video. Is it not working? Oh no. Okay. What about? Okay. Well, so sorry about that. Well, this was the main part of the presentation. So okay, so then I'll just talk over this slide. So basically, it's a full process with all the masks and all the kind of ML that we've applied to this kind of footage. Right. Okay. Well, unfortunately, you cannot see it. So it's not okay. Right. Well, some of the future work that we're planning to do is, that was David Attenborough talking about the color TV and the importance of color TV. And then if we were able to see it, you would also hear that audio is not that good. So the next step that we're planning to do is also use some of these transformer models to do the audio enhancement, and then we would have kind of a full restoration pipeline. At this point, this restoration pipeline is not fully automatic, but we've reduced the time significantly, meaning like we've done the automatic colorization, we've done the automatic segmentation, and the frame rate enhancement. So basically, we've interpolated, we've removed the frames that are presented with the physical damage and interpolated using machine learning models. So the next step is to do the same for audio, and then to try to kind of try to build out this pipeline, which is nearly automatic. So for example, for our colorization at the moment, we do have some issues with, for example, if you want to do automatic colorization based on an exemplar, then there's some color bleeding and some artifacts that are not well, let's say not desired and not perfect. And then to mitigate this, we actually have created a graphical user interface that a person can use, and then just give an input to the model what type of shades they want. So, for example, in this example here of David Attenborough, so you would kind of choose that the background needs to be in a shade of brown, and the face and the coat, the jacket in a shade of gray, and so on. So you know, there needs to be at this point some human involvement as well, but the time needed for the restoration of this type of videos is significantly shortened. So some other things that we plan to do in the future is we've also started building GPT BBC. So we've fine-tuned the GPT-J, Hugging Face open source model, on internal data set, which consists of around 500,000 BBC News articles. And we aim to kind of try and build better metadata, better text representation with these models. We aim to kind of do a semantic search with Q&A queries of some of our textual databases. So, for example, BBC has an internal database they call BBC Monitoring, where they collect all sorts of articles and media fragments from all over the world. And journalists at the moment, they kind of query it very manually, and it's like a keyword specific. And then one of the projects we're working on is actually to try build Google search for our internal database. And of course, the big thing we're also working on is to try and improve speech-to-text system with the OpenAI's Whisper. That's it. We have a lot of time for questions. Thank you.
Great presentation, thank you. Did you try any captioning of automatic captioning or description of the video material, which is not only a transcription but also the description of what is going on?
Automatic captioning of video.
Yes.
Oh yes, we call it synopsis.
Oh, okay.
Yes, we did try it, but a long time ago, and it wasn't that successful. So at the moment, we do not do it, but we are working on a video representation models. So maybe using both text and the video to kind of create a good representation of content that can be used downstream in the recommender systems we are building for iPlayer. But whatever assets we have at the moment on the iPlayer, the synopses are human-made, and they are really good. So you know, for the archive, we will probably look at it as well.
Good news is that the research has improved models significantly recently.
Good, thank you.
Yeah, basically my only question was to make sure that the current objective is to be able to transcribe all the audio, so in eventually like standard NLP techniques can be applied basically to analyze all these archive data, right? So to automate this transcription process.
Exactly. Okay. So there are like a couple of things. Like if you imagine like where BBC is at the moment, like we're competing with the likes of Netflix. So the traditional media is kind of slowly dying. And for us to be able to survive, we need to do two things. So we need to basically build our technology, build our streaming services to be better, to be global. And we need to make content, to offer a lot of content very fast. And we have like a treasure trove here. And what we want to do is help our content creators use it. At the moment, they cannot use it. So yes, the objective is to use NLP for this type of tasks.
Thank you.
Thank you for a wonderful presentation. My question is about technical details of restoration pipeline. So I imagine, I mean, I don't know how do you do it, but I imagine you start with high quality content and then degrade it, and you learn machine models to restore them back to the original quality. So can you please expand a bit on.
Well, there's a lot of parts to this like pipeline. So what you're referring to is like enhancement, like increase in the resolution, right?
Yes,
Yes.
denoising, increasing resolution.
Well, those are two different. Denoising is like one model, then another model is resolution increase, and then the damage, like removal of physical damage artifacts, is another model yet again. So yes, for this one, we would use a certain type of. It would be trained on a degraded images at the minute, and yeah, we have a lot of papers. So my team currently working on it is 5 people, and if you go to R&D, BBC R&D webpage, all of their papers are there. So some of the models that we use are attention-based models for the colorization, but for these resolution enhancement, I think it's like pretty much encoder-decoder generative architectures. So yeah, but yes. But of course, you know, there is a problem with the type of damage. So we have to kind of use the internal BBC data. So we have like also a database of 60,000 photos that are already restored by humans, and this is such a valuable data set for us. And then we use it to kind of address these physical damage artifacts, like to fine tune our models for that one.
Well, thank you.
Yeah. Okay. Yeah, well, one maybe sci-fi question for now, but I suppose you encountered the problems with pretty bad sound, where you can where you actually can't restore via this pipeline the quality of the sound. Have you thought about some audio deep fake? I don't know, audio deep fake. Restoration.
Yeah, well, that's an interesting question, because we are looking in this direction. We haven't tried it on this one, but we have one research stream that is around like a metaverse work. So meaning like creating 3D assets. Well, let's say like one historical or whatever, whichever footage we have most in the archive, using their archived voice and then using it as a way to generate, and then using NLP to in fact produce this Q&A. So if you can imagine, you know, maybe in 5 years' time, so we're looking in this direction that maybe in 5 years, 10 years' time, we'll be in a position where we can say, you know, if there is a platform, if there is a metaverse, I know it's a very controversial topic, but if there is a metaverse, maybe I'm pretty sure you are going to be able to go there, to go in a pub in a metaverse and talk to Richard Feynman about quantum physics. And, you know, the question is who is going to build it in a way. So, yeah, so we are looking in this direction for sure.
I have a question regarding the speech-to-text solution that you built. So you said that it wasn't viable to use third-party solutions for you.
It wasn't.
Yeah, and my question would be like, I'm not sure if I missed it, but why wasn't like a third-party solution viable for you?
Well, simply because we have like countless hours of videos, so it would kind of bankrupt the BBC almost. So, you know, it was very expensive. Like, even though at this point, you know, it's not that expensive to use Amazon services to transcribe, it's just simply unsustainable for such a huge archive. So it had to be in-house.
Okay, thank you.
Exactly, yes. Exactly, yeah, because the Amazon's really bad, like on Scottish and Northern Irish accent.